So there are 4 crops to plant, and there are some rules. Okay. Uh, no, no, no. Yep, so let me explain. So, one case is that only one plant is used to plant all the fields. So, for example, the crop is A, so all A's are planted on the field. So, because there are 4 types of crops, the choice is 4 and the arrangement is 1. So, there are 4 cases. And if we use 2 crops, 2 types of crops, and one crop is used for 3 fields, and the rest is filled with the second crop, because of the rule, we cannot use corn and wheat together in this arrangement because in such case the corn and wheat share a border. So if we choose corn, we should choose either soybean or potato. So let's say chose one corns and three corns and one soybean, so it will be filled like this, and then the S can be one of these four, right? This can be S, the soybean, or this can be soybean, like this. So there are four arrangements. So So in the case of corn, it can pick either soybean or potato for its partner. So two cases, and in the case of wheat, it can choose either soybean or potato too. And if soybeans are chosen three times, it can choose corn or wheat for its partner, and potato three times. Potato can also pick either corn or wheat. So I mean, so the choices are eight, and the arrangement is four. So the total case is 32. And the third case is we want to plant two of the fields for one crop and two of the fields to the other crop. So in this case, the choice is also eight, and the arrangement is so this is one arrangement, or this is this way. How can I say? Actually, in this case, I should say the choice is 4 and the arrangement is 6. Am I right? Yep. So, if let's say this is A, B, C, D. So, I mean, how can I say? So, corn, SS. Soybeans. Yep. These are four choices and the arrangement is 6. So, the case is 24. And if we want to use three crops, if we choose the two fields for one crop, and the rest is assigned to each of the remaining crops. So for this arrangement, we have like this. So these are four choices, and the arrangement is, and we can exchange B and C, or we can pair the other diagonal with A, and then we can exchange B and C. So the arrangement is 4. So 4 times 4 is 16. And finally, if we want to fill each field for uh, the different crops, so if corn is planted here, the wheat should be planted here because they cannot share a border. And then SP like this. And we can exchange SP and CW. So there are four cases, and we can exchange the diagonal. So CW or SP. So once again, they can move back and forth, and SP can move back and forth. So four cases. So one choice and eight arrangement. So the possible case is eight. So the sum of these five is 84. So there are total 84 possible cases. Yep. Let's go to number 19. So in this case, a disk fills inside a square, and a second disk is around the square. So if there is a square like this, when this disk moves sideways or up and down, it cannot fill this region. This region cannot be swept by the disk. And in the middle, this region is also not touched by the disk. So for this area, we need to subtract this not touched area from the total area of a square. And because the side length is s, the area is s squared, and minus mm, the middle small square, the area is because the disc's radius is 1, this length is s minus 4. And then we need to subtract 4 of these, the corners. So if we um, move all the corners in one square on the uh, right upper right, uh, this square's area is 4, and um, the area of one circle is pi. So so that's the area swept by the movement of the disk inside the square. And for the outside, For the outside, a circle will move around on this square, and at the corner, it turns like this. So the area swept by the disk, we need to add the area of these rectangles. There are four rectangles, and there are four sectors. And this area makes the 2A. So 2A is the area of each rectangle is S times 2. So 8S. 4 times 2S is S, 4S, 8S. And then for the corners, when we add these four corners, that will make a circle. And the circle's area is 4 pi because the radius is 2. So that means if we divide the second equation by 2, and that's equal to the area from the first equation. So if we simplify the first equation, and then when you solve this equation of 4s, yep, so this is the value of s, and if we compare this to a plus b pi over c, yep, so what's the sum of a, b, and c? Yep, when you compare these two expressions, yep, so a is 5 and b is, yep, c is, yep, so that means the sum is, yeah, 10 is the answer. Yeah, for number 20. So have of real solutions, distinct real solution. The discriminant should be greater than 0. So from the first equation, the first discriminant is, and for the second discriminant, let's make this inequality using Desmos. Although the calculator cannot be used in AMC, just let's just use it for this class to make things look clear. So I'm going to change variable b and c to x and y. And that means this is first inequality. Am I right? I mean something distinct real solution. Something, yeah, but no, something is not right. Uh, do not have. Sorry, do not have. So the direction is the opposite. I mean here, don't. So so if we think of the pairs in the overlapping region, positive integer pairs. Yeah, so these are the four pairs inside the overlapping region. And I think we should include the equal sign here. Am I right? Do not have a distinct real. So, although it's real, if it's not distinct, that satisfies the condition. So, uh, not distinct real solution means we can include this equal sign. In such case, there will be the double root. Double root means um, only one real solution. So that's not distinct. So in this case, we can include 1 and 2 and 2 and 1. other points are not included. Yep, so there are these 6 points. So 6 pairs are possible. Yeah, 6 pairs. Yep, so here, in the case of P, there are the 3 balls and 5 balls. The bins containing 3 balls and 5 balls, and the other 3 bins are with 4 balls. And in the case of Q, all the bins have the 4 balls. So in the case of P, to make the bin of 5 balls, we pick 5 balls out of 20 balls. So the choice is 20 C5. In this case, the C is called computation. Comp computation, am I right? Yeah. Permutation, combination. Yeah. And then the next is 3 balls. So we need to pick 3 balls from 15, and then from that then on, we continue to pick 4 balls. And because there are 3 equal bins having the 4 balls each, we need to divide this by 3 factorial. And in the case of Q, all the balls have 4 balls, so in this case we need to divide this combination by 5 factorial. So we don't have to think of the 3 bins containing 4 balls. So if we compare only with 5 balls and 3 balls and two four two 4-ball bins from the queue, and then we make this 3 pack and 5 factorial, I mean reciprocally. And then mm, uh, in the case of 20C5, uh, we need this 5 factorial at the bottom. And for the 15C3, we need 3 factorial. And these 4 factorials, they make this 4 factorial, and this 4 factorial goes up because that's reciprocal. So if we simplify this expression, only 4's remain at the top. So the answer is 16. Hmm. So 3 spheres are inside the circular cone. So if we connect these 3 spheres, the center, we can make this blue equilateral triangle. So we want to find the distance from one of the center of the small circle to the center of the big circle. Big circle means the base of the circular cone. Uh, the distance is the red line in the figure. And if we make the coordinate plane for the side of the cone, the red line is also expressed in the coordinate plane. So if the radius of the small circle, small sphere is r, because the side length of the equilateral triangle is 2r. The red line's length is uh, because the center of the circle, the base circle, how can I say, this point, this center is the orthocenter in terms of the equilateral triangle in this case. So that means uh, the orthocenter divides the median but with a ratio of 2 to 1. So the height of this equilateral triangle is uh, square root of 3 times r. 2, 1 square root of 3, and so that means the red line's length is this length. They are the 2/3 of square root of 3 times r, because the height is square root of 3 times r if we divide the height with a ratio of 2 to 1. So we can make the coordinate of one of the sphere in this coordinate plane minus r and no. So we can make the coordinate for the center of the little sphere, and because the circular cone has the radius 5 and 12, we can think of the x-intercept and y-intercept this way, because it's in the second quadrant in this coordinate plane. So with the intercept, we can make equation of the line. Uh, so this is the equation of the line. So if we make the standard form of this equation, and then we want to find this distance from the center to the line. This distance is also r, the radius of the sphere. And in this case, we are going to use the formula to find the distance between this point to the line. If we use the formula, we get this expression. We put these points to x and y in the equation. So if we solve this for r, And if we rationalize the denominator, yep, so this is the value of r for the radius of each sphere. So in this case, the answer is B. Yeah. Yep, so let's start with the number with the only one factor. Actually, such number uh, is only one, right? So if we start from number one, uh, we make the twice the number of the factors. So if it has one number of factors, it becomes two, and two has two number of factors. So multiply two, and two makes four, and four has three number of factors, three factors. So twice over three is six, and six has four factors, and four times two is eight, and 8 has 4 factors, so 4 times 2 is still 8. So that means 8 is a dead end, and we cannot change uh, 8 to other numbers. So if a number has 2 factors, such number is a prime. If it's a prime number, we start from number 2. I mean, 2 factors. So the application of the function makes 4, and it follows the 2 4 6 8. So once again it's a dead end, it cannot be 12. And if the number of factors is 3, multiply 2 to 3 makes 6, and 6 has 4 factors, so multiply 2 is 8. So if we meet 8, it's a dead end. And if it, uh, if a number has 4 factors, it follows the path of 4 6 8, so not 12. And if it has 5 factors times 2 is 10, and 10 has 4 factors, so 4 times 2 is 8. So when we meet 8, it's that. And if a number has 6 factors, 6 times 2 is 12, and 12 also has 6 factors, so 6 times 2 is 12. So 12 doesn't change. So 12 is still 12 when a function is applied. So that's the case we want. So we need to find the number which has 6 factors from 1 to 50. So one such number is 32, 2 to the fifth power, because 32 has 6 factors. So these numbers have the 6 factors. And if a number has 9 factors, 9 times 2 is 18, and 18 has 6 factors, so that become 12. So that's the case we want. And if a number has 10 factors, 10 times 2 is 20, and 20 has 6 factors, so 6 times 2 is 12. Yep, so these are the numbers which make the f of n is 12. So the number of, how can I say, how many numbers are here? So there are 10 numbers from 1 to 50. Oh, no, no, not this. Yeah, 10 numbers. I'm going to label edge with one red and label edge with 0 blue. So all the faces, uh, the sum of the labels on the edge is 2. That means there will be the 2 red edges and 2 blue edges to make each face. So this is one example. Now all the faces have the 2 red lines and 2 blue lines. This is another example. Uh, Yep. So in this case, I'm fixing these two. Let's say these two are adjacent, and there is one case for uh, this line, and for the right face, I mean the third red line may be here, and there are two cases. Uh, the red line is at the bottom or on the side, or for the third side, it's parallel, right? I mean, one case for this, two case for this, and one case for this. When you set these two lines are adjacent. So there are four cases when two lines are adjacent, the red lines are adjacent. And this is one case when two lines are parallel at the top face. And we can reflect this, how can I say? I'm starting with the right edge is adjacent to the front edge at the top face. So we can think of the second case is the left edge is adjacent to the front edge at the top face. So we start from this, not this. So if we start with this adjacent case, we will make the four pair of each case. We can make each case when the left side is adjacent to left edge is adjacent to the top front edge at the top face. And then for this case, we can think of the two sides are parallel. Two red, I mean this way. So these two sides are parallel like this. No, 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 not exactly. Not this way. Not this way. Alphabet. In this case, it goes like this. Because this case, this one is red, so the next one we can think of is this one is red. So we can make the same case for the mirror image between the left and right. So that means there will be the 10 cases, and then we can flip the red to blue and blue to red. So uh, out of these 10 cases, there will be also the pair when you exchange blue and red. So the number of total cases is 20. Yep. Uh, Actually, I made a video for this problem, so I'll send you the link. And if you are not sure about this, you can look at the video again. Yep. Let me give you the link now. Yep, this one. Yeah, where are you? Okay. What is this? Yep. And yep. Yeah. Let's solve the last problem. I made also the video for this problem, so I'll briefly explain. Uh, and I'll also send you the link. Well, let's see. Ah, yeah. So here, there is a quadratic polynomial, so we can say the p of x is the x minus alpha and x minus beta. The quadratic means it has x squared, and the coefficient is 1. And the p of x, that will make the x to the fourth power. And when this equation is 0, there are three real solutions. So if we make p of px, three solution means one of them has one root, and the second parenthesis will have two roots. And having one root means uh, the discriminant should be 0. Having one root means in this case the double root. Double root means the perfect square. To have a perfect square, the discriminant is 0. So when we uh, solve this equation in terms of alpha, so alpha is equal to this expression with beta, and we want to make the sum of the roots is maximized. So the sum of the root in this case is alpha plus beta, and if we change alpha to the expression for beta, we get this expression, and we substitute k for square root of 1 minus beta, and it becomes the quadratic expression for k, and we can find the maximum value with by making perfect square uh, for this quadratic expression. So that means when k is 1 over 2, the sum of alpha and beta is the maximum. The maximum value is 1 over 2. So when k is 1 over 2, beta is 3 over 4, and when beta is 3 over 4, alpha is minus 1 over 4. So now we know the value of alpha and beta, so we can make the polynomial with the roots. And then finally we want to find the p, this wave of 1. So when x is 1, the first parenthesis is 5 over 4, the second one is 1 over 4. So what's the product? What's the product of these two fractions? Yep, 5 over 16. Yep, that's the answer. Yep. I also have a video for this, so I sent you the link. Yep, this one. Oh, yep, I think that's enough for today. So, yep, keep doing your homework, and let's just see on Sunday. Yep, you have a good day. Bye.